Hello guys, this is Akash. Welcome back to this YouTube channel Nursery with Lecture. In this video, I am going to discuss another chapter, that is 3D geometry, in the top 10 question series for JEE Advanced 2023. Before that, I already completed the vector algebra session, but I forgot to upload the 3D geometry. So now I am recording the video and I will upload in day after tomorrow. So it will be really beneficial for you because the vector algebra, after completion of the vector algebra, if you study the 3D geometry, there is something related between vector algebra and 3D geometry, so you can easily understand the 3D geometry. And also this 3D geometry weightage is very high in the JEE Advanced. In JEE Advanced 2022, if you see, nearly 2 to 3 questions came in the JEE Advanced 2022, so it is really important. And also these 2 to 3 questions are not alone in 3D geometry. It is a mix of concepts. The 3D geometry is involved as matrices. It can be anything, but you have to understand one thing: this chapter has weightage, so you can able to answer some of the questions. At least if 3 questions are given, you can easily make 2 questions out of 3 questions in 3D geometry. So it is really important. So and before going into this video, if anyone didn't join the Telegram group, join the Telegram group also, because it is really important to get the notifications and the remaining stuff here. So it is very important. And also the practice sheets as well as the notes will be shared in the Telegram group. So if you want to access those notes and the practice sheets as well as the updates and also this video's notifications, you have to subscribe to this channel as well as join the Telegram group. So now let's get into this video. The first question they given us: if the straight lines x minus 1 by 2 equal to y plus 1 by k equal to k by 2 and x plus 1 by 5 equal to y plus 1 by 2 equal to k, z by k are coplanar, then the planes containing these lines are. What they asking? They given these two are the straight lines and these two straight lines are coplanar. Now what they are saying, then the planes containing these two lines. So suppose if you name this line as L1 and if you name this line as L2, this is a plane, line 1 and line 2. These two lines are containing and these two lines are coplanar. So you can easily apply the coplanarity condition. What is coplanarity condition? The coplanarity condition is if the two lines are coplanar, it can be parallel lines or it can be intersecting lines. So for anything, you have to first of all make this form. That is, you have to consider this line. So what is the passing point? Here it is 1, minus 1, it is 0. And for this line, the passing point is minus 1, 0. And what are the drs here? 2, k, 2. And what are the drs here? Their drs is 5, 2, k. So if you observe very carefully, what is a2 minus a1 here? So we have to minus these two things. So minus 2, 0, 0. This is a2 minus a1. What is b1? b1 is 2k2. What is b2? It is 5, 2k. So if you observe, if you apply the coplanarity condition, the coplanarity condition says that here a2 minus a1, this complete row, and here b1, here b2, you have to apply. So what is a2 minus a1? Minus 2, 0, 0. Here it is 2k2. Here it is 5, 2k. So minus 2 into k square minus 4, that's it, is equal to 0. And minus 2 into k plus 2 into k minus 2 equal to 0. So k can be minus 2 and k can be 2. When k is k equal to 2, you can write here. When k equal to 2, when k is equal to 2, you can see, wait a second, here it is k, here it is k. So now it is k equal to 2 and k equal to minus 2. When these are the given points, suppose I am replacing here k equal to 2 here and here k equal to 2, what I will get? I will get the 4 points. And now what we can do? By using these things, you can easily generate the plane. How you can generate the plane? You can easily generate the point. Suppose I am considering this point 1, minus 1, 0. This is a passing point I am considering, and after considering, I can cross product these two things. That is I, j, k, 2, 2, 2, 5, 2, 2. So I into 4 minus 1, 0. Here it is minus j into, it will be 4 minus 10 here and plus k into 4 minus 10. So what I will get? Here it is 6j. Here it is minus 6k. This is a thing and this is a cross product. So the plane equation is r dot n equal to a dot n. R is x comma y comma z and n is this thing 0 comma 6 comma minus 6 equal to 0 comma 6 comma minus 6 into what is the passing point I consider 1 comma minus 1 comma 0. Now if you observe carefully, here it is 6y minus 6z equal to, here it is minus 6, just minus 6. So what is the plane? Y minus z equal to minus 1. Y minus z equal to minus 1. This is one equation. Option C is correct. Another equation you have to find. Another equation is when k equal to minus 2. When k is minus 2 here, when k equal to minus 2, and by doing the cross product, you can easily make the difference here. Here it is minus. So at this time, what will the determinant here? I into 4 minus 4, again it is 0, and now j minus j minus 4 minus 10 plus k 4 plus 10, yes, it is 14j plus 14k, yes. So this is the thing. Again we are doing rand out n. I kept this name as rand out n because you can easily understand ran equal to n. Ran is nothing but r equal to the general point x comma y comma z. N is the cross product term, and a is the point which we consider, and n is the again the same, the normal vector. So ran dot on x comma y comma z into x comma y comma z into what is n? N is this thing, 14 into 14, 0 comma 14 comma 14, and here it is 0 comma 14 comma 14 in dot. What is here into what is the considering point 1 comma minus 1 comma 0. So what is the answer now? Now 14y plus 14z equal to, now the answer is minus 14. So y plus z equal to minus 1. Y plus z equal to minus 1. Y minus z equal to minus 1. Y minus z equal to minus 1. These two are the things. Wait, I will check the answer. Y plus z equal to minus 1. Y minus z equal to minus 1. Yes, these two things are correct. So this is the first question completed. This is the first question. Now second question. Two lines L1 x equal to 5 comma y divided by 3 minus alpha equal to z divided by minus 2, and line L2 x equal to alpha y divided by minus 1 equal to z divided by 2 minus alpha or coplanar, then alpha can take values. This is solution. Sorry guys, I got the call. Sorry guys. Yes, now it is okay. Two lines, these two lines are given, and these two lines are coplanar. So then alpha can take the values. When it is coplanar, it is very clear. First of all, we have to make the lines very neat. Line L1 we can make as x minus 5 divided by 0 equal to y minus 3 minus alpha equal to z divided by minus 2. This is line L1, and line L2 is x minus alpha divided by 0 equal to y minus 0 divided by minus 1 equal to z divided by 2 minus alpha. And here, wait, I forgot to give the options here. Option A is 1, option B is 2, option C is 3, option D is 4. Now if you observe carefully, these two lines are coplanar, they said. So when the lines are coplanar, we have to first deduce the points 5 comma 0 comma 0. This is a passing point, and the DRs are 0 comma 3 minus alpha comma minus 2. And for this line, it is alpha comma 0 comma 0. Here it is 0 comma minus 1 comma 2 minus alpha. These 2 points. So in order to make these two lines coplanar, this thing, that is a2 minus a1, we have to another thing we have to calculate, alpha minus 5 and 0 comma 0. This is a2 minus a1. Now we have to fill a2 minus a1 here, and another b2, that is the direction ratios we have to fill here. here another direction ratio 0, minus 1, 2 minus alpha, and if you do alpha minus 5 into, now what you will get here? You will get here 3 minus alpha into 2 minus alpha minus 2, and here alpha minus 5 into 3 minus alpha into 2 minus alpha minus 2 into alpha minus 5. This thing is equal to 0. This thing is equal to 0, and again, and if you see carefully here, what are the points it is coming? So you can clearly see here, for what values it is 0, we can take common alpha minus 5. Alpha minus 5 you can take common. If you take alpha minus 5 as common, alpha can be 5, and again this thing is also should be calculated. 3 minus alpha into 2 minus alpha, how much it is? It is alpha square minus 5 alpha plus 6, and it is minus 2, so it will be plus 4. For plus 4, what we can do? 4 alpha, 4 once it is, so it is minus alpha plus 4. So alpha taking common, alpha minus 4 minus 1, it is alpha minus 4, so alpha equal to 4 and alpha equal to 1. So alpha can be 5, 4, 1. What alpha cannot be? They asked, then the alpha can take the values. Alpha can take the values 1, 4. So option A, option D are correct. So like this you have to solve this question. Yes, the answer is correct. I am checking the every answer because it is important to make sure that what I am delivering is correct and relevant to you. The second question is completed. Now third question. The equation of the plane passing through the equation of the plane passing through the equation of the plane passing through the point 1, 1, 1 and perpendicular to the planes 2x plus y minus 2z equal to 5, and another plane is 3x minus 6y minus 2z equal to 7 is option A, option B, option C, option D. 14x plus 2y plus 15z equal to 31, 14x plus 2y minus 15z equal to 1, minus 14x plus 2y plus 15z equal to 3, 14z minus 2y plus 15z equal to 27. Now let's solve this question. What they are saying, they saying the equation of the plane passing through the point. They given the passing point, that is 1, 1, 1. What they are saying, the plane should be, what are the planes we are going to going to solve. Those that plane should pass through the 1, 1 point, and it should be perpendicular to these planes. Suppose these two are the planes and this is the required plane, and this plane should be perpendicular to the given two planes. So if you observe carefully, if it is perpendicular, what are the direction ratios are present to these things? Suppose this direction ratios is 2, 1, minus 2. And what are the direction ratios? It is 3, minus 6, minus 2. These two direction ratios, suppose this is a plane, these two direction ratios will be like this. So if you want to have the direction ratios of these, you can do the cross product of these two vectors. This is one vector and this is another vector. If I separate a2 minus a1, and if I do, this is a1, this is a2, if I do the cross product a1 cross a2, I can get the perpendicular vector. So this perpendicular vector is a normal vector for this perpendicular plane, and this perpendicular plane have the normal vector this by doing the cross product between these two. So what I am saying is, in order to find the plane passing through the 1, 1 and perpendicular to these planes, we need the normal point, that is normal vector coordinates drs, and the passing point. The passing point is given. To find the normal vector, we are going to do the cross product here. That is j, k, 2, 1, minus 2, 3, minus 6, minus 2. So it will be I into minus 2 plus 12, it is minus 12, minus j into it is a minus 4, and in here it is minus 6, so plus 6 plus k into it is 12 minus 3, minus 12 minus 3. So what it will be? Minus 14i minus 2j minus 2j, and here it is minus 15k. You can observe carefully, minus 49 minus 2j minus 15k is a normal vector, and this is the passing point. After knowing these two things, I can know one formula: r dot n equal to a dot n. Here n is a normal vector, a is the passing point, r is nothing but the general point x comma y comma z. So dot n cap it is minus 14 minus 2 minus 15, and this thing is equal to minus 14 minus 2 minus 15, and the passing point dot product, the passing point dot product 1 comma 1 comma 1. So here it is minus 14x minus 2y minus 15z equal to minus 14 minus 2 minus 15. So if you observe carefully, if I multiply with the minus, it will be 14x plus 2y plus 15z equal to how much it is the sum? 14 plus 2 it is 16, 16 plus 15 it is 21, 31. So it will be 31. So 14x plus 2y plus 15z equal to 31. 14x plus 2y plus 15z equal to 31. So option A is correct. Like this you have to solve. The third question is also completed. Now fourth question. Now fourth question. Let alpha, beta, gamma be real numbers such that the linear equations x plus 2y plus 3z equal to alpha, 4x plus 5y plus 6z equal to beta, 7x plus 8y plus 9z equal to gamma minus 1 is consistent. Let mod m be determinant of matrix M, that is alpha 2 gamma beta 1 0 minus 1 0 1. Now this complete what we up to now what is written, this is completely matrices and determinants. But why I am discussing here? Because after this part the 3D geometry question is starting. What they are saying? Let P be the plane containing alpha, beta, gamma, for which the above system is consistent, and the given D is the distance from point 0 comma 1 comma 0 from the plane, then D square is, look at guys how much big it is question, total board it is filled up. So I can make the calculations here. After completing these parts I can rub the what is not needed. So up to this it is matrices and determinants, and after this is completely belongs to 3D geometry. So in JEE Advanced like this mixed questions will come, and this question is JEE Advanced 2022 question. Now first of all, let's alpha, beta, gamma be real numbers such that this linear equations is going to be consistent. So in order to be consistent, what we check? First we check the determinant of this. What is the, suppose if you assume this as this linear equations like this 1 2 3 4 5 6 7 8 9, if you find the determinant it will be 0. You can check 1 into 45 minus 48 minus 2 into 36 minus 42 and plus 3 into 32 minus 35. You can 32 minus 35, it will be minus 3. So you can solve and you can get the determinant as 0. And if determinant is 0, two conditions in Cramer's rule. Determinant not equal to 0, determinant equal to 0. Determinant not equal to 0, unique solution that is consistent. And determinant equal to 0, two conditions again. One is infinite solutions which is consistent. So here it is determinant 0. So and they are saying it should be consistent. So what are the solutions possible? It will be infinitely solutions. So and after knowing the infinitely solutions, what we can do? We can find d1, d2, d3 because d1, d2, d3 should be equal to 0. All d1, d2 and d3. So I am finding the d1. What is d1? Replace this column here. What you will get? You will get alpha, here beta, here gamma minus 1, here 2, 5, 8, 2, 5, 8, here 3, 6, 9. If you solve this, alpha into 45 minus 48 minus 2 into 9 beta minus 6 gamma plus 1 and plus 3 into 8 beta minus 5 gamma plus 5. If you solve this, what you will get? Here it is minus 3 alpha, here it is minus 18 beta, here it is plus 12 gamma, here it is minus 2, here it is 24 beta, here it is 15 gamma, here it is 15. So when you solve this, you will get minus 3 alpha, right aside, minus 18 beta, here 24 beta, it will be 6 beta. Here it is 12 gamma, it is 15 gamma, it will be minus 3 gamma. And here it is minus 2 plus 15, it will be, 1 second guys. Here, sorry, it is 6 here. 6 here, 6 to 12 it is. So it will be plus 3. So this is the thing, and it should be equal to 0 condition. And if we divide with minus 3, you will get alpha minus 2 beta plus gamma minus 3 equal to 0. This is a most important condition from which we deduced from here. And they are saying let m be the determinant. There is no need of this part because if you calculate the determinant, it is the same alpha minus 2 beta minus plus gamma equal to 3. It will come like this. This is a determinant. And also it is not 3 here, it is 1. So we can get like this. Alpha minus 2 beta plus gamma. This is a determinant. This is the matrix M. For this matrix M, if you find the determinant, that is alpha into 1 minus 0, minus 2 into beta and plus gamma into plus 1. If you do the things, you will get this. And this is a determinant. And what is the determinant of M? It will be 1. So if this is the second part of the question, there is a first part of the question which I discussed in the matrices JEE Advanced series. So matrix JEE Advanced series I discussed. In matrix JEE Advanced series, first question is this, to finding the modem. Modem is, that is determinant of M is 1. This question also now completed. Now what they are saying, let P be the plane containing alpha, beta, gamma. Alpha, beta, gamma, if it is consisting, I can replace alpha, beta, gamma as x, y, z. So simply x minus 2y plus z minus 1 equal to 0. I replace it now. For which the above system is consistent. Okay, yes, it is consistent only because alpha, beta, gamma are the points used in this, used from the system of linear equations. So it will be consistent only. And now they are saying d is the distance from the point 0, 1, 0 from the plane. If whenever the question is saying from the plane distance, it will be perpendicular distance. So now our work is to calculate the perpendicular distance. Perpendicular distance. What is perpendicular distance from the plane? What is the point given? Oh, sorry, I rubbed the point. Wait, I will find. The point given is 0, 1, 0. 0, 1, 0, and the plane is x minus 2y plus z minus 1 equal to 0. The perpendicular distance is x minus 2y plus z minus 1 divided by root of 1 plus minus 2 whole square plus 1 square. If you calculate this, you will get, and you have to substitute this point here, you will get here minus 3 divided by root 6 mod. And this is d value, this is distance, but they asked what? D square. So if you square this, you will get 9 by 6. So it will be 3 2's 3 3's. It will be 3 by 2. What is 3 by 2? It will be 1.5. So d square value equal to 1.5. What is d square? D square value is 1.5. So the answer for complete question is 1.5. from complete question. Like this you have to solve. The question is completed. One second, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, sixth question. Now, sixth question, guys. 3 lines are given by r bar, that is equal to lambda I cap. Lambda belongs to r, and r bar equal to nu into I plus j, and nu belongs to r, and r bar, the vector is same, but there is a slight change in the components of I cap, j cap, k cap. So and finally r bar equal to gamma into I cap plus j cap plus k cap. Gamma belongs to r. Let the lines cut the plane x plus y plus z equal to 1 at points what? At points a comma b comma c. If area of the triangle, if the area of the triangle ABC is triangle, that is delta, then they are asking, then 6 delta whole square. What is 6 delta whole square? Now it is a solution part. What are given? 3 lines are given. Whatever lines it will be, first we are going to understand the question. There is a plane x plus y plus z equal to 1, and there are 3 lines. 3 lines are intersecting the plane. Here one point, here another point, and here another point. This is point A, this is point B, this is point C, and if you join this, you will get a triangle. And for this triangle, the area is triangle, that is delta, and they are asking 6 into delta whole square they are asking. This is a simple question. First, the plane is given, lines is given, we have to find the point of intersection of line and plane. You will get a point, A, B, C. After getting 3 points, you can able to find the delta area. So first of all, first point, that is r cap equal to lambda I cap. So I can write this general point as lambda comma 0 comma 0, and another point that equal to nu into I plus j. It can be nu comma 0. So again r cap, it will be gamma into I cap plus j cap plus k cap. I can write as gamma comma gamma comma gamma. Now these 3 points I can substitute in the plane. What the plane is given, x plus y plus z. To find the point of intersection, we have to substitute like this. This is a general points, I assume. Why I taken? Because these are the components of x, that is I cap and j cap and k cap. So what are the components of I cap, j cap, k cap are present? Those I can take as a general points. So these points are I can substitute here. First point is lambda plus 0 equal to 1. So lambda equal to 1. So what is the point? 1 comma 0 is 1 point, and nu comma 0. It will be nu plus nu equal to 1, 2 nu equal to 1, nu equal to 1 by 2. Another point, 1 by 2 comma 1 by 2 comma 0. Another point, gamma. It will be gamma plus gamma equal to 1, 3 gamma equal to 1, gamma equal to 1 by 3. So another point is 1 by 3 comma 1 by 3 comma 1 by 3. These are the point of intersection of line and plane. Now we find the 3 points. Now what is our work? Now? What are the points? 1 comma 0 comma 0. Another point 1 by 2 comma 1 by 2 comma 1 by 2. No, it is 0, because here we got 0 here, and 1 by 3 comma 1 by 3 comma 1 by 3. Now we have to find the area. Suppose if we assume this point as A, this point as B, this point as C, I can able to write AB. AB vector. What is AB vector? AB vector is minus 1 by 2 comma 0. What is AC vector? AC vector is 1 by 3 minus 1, 1 by 3, 1 by 3. It will be minus 2 by 3, comma 1 by 3, comma 1 by 3. Yes, it is AC. So in order to find the area, what I can do, half mod, that is mod AC, half mod AB square. I can use the triangle formula, AB square AC square. I can use this formula. How I got this formula? This is a triangle. If I use a parallelogram draw, what is the area of parallelogram? If the sides are given adjacent sides, it is AB bar cross AC bar. It is A, it is B, it is C. AB bar cross AC bar. But it is half of the parallelogram. So it will be half into AB bar plus AC square. This is a triangle area. This is a triangle area. Very important. Now half into, we have to do the cross product. I, J, K, what the points are given? AB, that is minus 1 by 2, 1 by 2, 0. And AC point minus 2 by 3, 1 by 3, 1 by 3. So I into 1 by 6 minus J into minus 1 by 6. Yes. Plus K into minus 1 by 6. And here it is plus 1 by 3. So finally the point is 1 by 6 I cap plus 1 by 6 j cap, and here it is 6 LCM minus 1 plus 2 here. Here it is 1 by 6 only. 1 by 6 k cap. K. You can easily get 1 by 6 I cap plus 1 by 6 j cap plus 1 by 6 k cap. Now simply we have to find the modulus of this. We have to find the modulus of this cross product. What is the modulus of this? It is 1 by 36 plus 1 by 36 plus 1 by 36. So what we got? We got 3 by 36. It will be 1 by 12. That is 1 by root 12. We got 1 by root 12. So 1 by 2 into 1 by root 12. And 1 second guys. Yes, it is 1 by 2 into root 12. Root 12 can be written as 4 into 3. Root of 4 into 3, it will be 2 root 3. 2 root 3, and this is 1 by 4 root 3, and 1 by 4 root 3 we have to multiply with 6, and we have to do square because they asked for 6 delta square. So this is 2 3's, 2 2's. So 3 divided by 2 root 3 whole square. So it will be 3 square 9, 2 square 4, 4 3's are 12, 3 3's 3 4's, 3 by 4. What is the value of 3 by 4? The value of 3 by 4 is 4 7's 28. Here it is 2 0 4 5. So the final answer is 0.75. So the final answer is 0.75. So the complete answer we got 0.75. This is answer you have to report. The sixth question is completed. Now, sixth question is completed. Now, seventh question. This question is really important, guys. Let alpha, beta, gamma, delta be real numbers such that alpha square plus beta square plus gamma square not equal to 0 and alpha plus gamma equal to 1. Suppose the point 3 comma 2 comma minus 1 is the mirror image is a mirror image of the point 1 comma 0 comma minus 1 with respect to the plane alpha x plus beta y plus gamma z equal to delta, then which of the following statements is are true? Which of the following statements is or true? And what the given option A, option B, option C, option D as alpha plus beta equal to 2, delta minus gamma equal to 3, delta plus beta equal to 4, alpha plus beta plus gamma equal to delta. Now what we have to do, let alpha, beta, gamma be the real numbers, and they said very clearly alpha square plus beta square plus gamma square not equal to 0. I already said in so many videos, this is not relevant to the question, but it is relevant to the question. There is no need to mention here. We can skip this, but it is very important. We have to understand how and why they are given like this, because while solving definitely there is a mathematical violation. So in order to avoid mathematical violation and in order to avoid the error in the question, they mentioned clearly that alpha square plus beta square plus gamma square not equal to 0. Let's see how it is. Let alpha, beta, gamma they are given like this, and they say and alpha plus gamma equal to 1. Suppose the point 3, 2, minus 1 is a mirror image of the point 1, 0, minus 1. So this is a mirror image of this point. This is a point. Suppose this is a plane. You can assume this is a plane, and the point is 1, 0, minus 1. And for this point, the mirror image is 3, 2, minus 1. Yes. And if you know the distance from the plane, both the distances are equal. So the midpoint definitely lies in the plane. So what is the midpoint here? The midpoint is 2, 1, minus 1. Yes. This 2, 1, minus 1 definitely lie in the plane. What is the plane given? The plane given is alpha x plus beta y. Beta, 1 second guys, it is beta y. Wait, I will check. Yes, it is beta y. Beta y plus gamma z equal to delta. So this point I have to substitute here. So it will be 2 alpha plus beta plus gamma equal to delta. So I got this relation. This relation is really important to find the unknown values. And after finding this relation, another thing, what we can make understand. And what we can think here. So I can make the DRs. This thing DRs. It will be proportional to the DRs of this. The DRs of the plane. What are the DRs of this point? It will be 2, 2, 0. This 2 to 0 are the proportionalities of alpha, beta, gamma. So it will definitely proportional. 2 by alpha equal to or you can take alpha by 2 equal to beta by 2 equal to gamma by 0 equal to lambda. You can take alpha equal to 2 lambda, beta equal to 2 lambda, gamma equal to 0. These things we got. Now substitute here. Alpha equal to 2 lambda, it will be 4 lambda, it will be 2 lambda, it will be 0 equal to delta. So it will be 4 lambda plus 2 lambda, it will be 6 lambda, 6 lambda equal to delta. So delta equal to 6 lambda. We got another relation. Now we have to simply do this thing. First alpha plus beta equal to 2 they say. Alpha plus beta. One second guys. Up to now what we did is correct only. There is no problem. Now let's substitute all the values here in the plane. Alpha equal to 2 lambda. If alpha equal to 2 lambda, what you can get? We have to find the lambda here. Is this correct? These things we got. Up to now what we did is correct only. Now we have to check. Wait. They given alpha plus gamma equal to 1. Alpha plus gamma Alpha plus gamma equal to 1. Yes, alpha plus gamma. What is gamma? 0. What is alpha? 2 lambda equal to 1. Lambda equal to how much? 1 by 2. Yes. When lambda equal to 1 by 2, it will be 3. Delta will be 3. When lambda equal to 1 by 2, alpha equal to 1 and beta equal to 1. Now it is clear. Now first option, it will be alpha plus beta. What is alpha plus beta? The condition is I forgot and to use the condition. So by using this condition, I have to find the lambda. We cannot generalize the thing. We have to find the particular value of lambda. Alpha plus beta. What is alpha? 1. Beta is 1. So 1 plus 1 it is 2. The option 1 is correct. Delta. What is delta? 3. Second option. It will be delta is 3 minus gamma. What is gamma? Gamma is 0. It is 3. They given 3. Yes, it is correct. And third option they given delta plus beta. Delta is 3. Beta is 1. It will be 4. It is also correct. And fourth option, alpha plus beta plus gamma equal to delta they given. That is 3. Alpha plus beta. Alpha plus beta is 2. 2 not equal to 3. So this option is wrong. So option A, option B, option C are correct. Like this you have to solve. This is 7th question. This is 7th question. Now 8th question. Now 8th question, guys. Three lines L1 equal to lambda I cap, lambda belong to R, L2 R bar equal to K cap plus nu J bar, nu belong to R, and L3 R bar equal to I plus J plus gamma K cap, gamma belong to R are given. These things are given. For which points Q and can we find a point P on L1 and a point R on L3 so that P, Q, R are collinear. This is the question, guys, very important. 3 lines are given. L1 equal to lambda I cap, L2 equal to K cap plus nu J cap, and L3 equal to I plus J plus gamma K cap. These 3 things are given. Now what they are saying, these 3 lines, suppose there is a point P in the R, there is a point, this P is lying on L1, Q is lying on L2 and R is lying on L3. These 3 points are lying on L3 in such a way that the points are collinear. So what I can assume? I can take here the point lambda comma 0 comma 0 and I can take the point here as 0 comma nu comma 1 and I can take point here. What is the point? 1 comma 1 comma gamma. These 3 points I taken general points. Now I have to, what I have to do? This I am assuming as P, this I am assuming as Q, this I am assuming as R. Now I have to find what is the condition required for PQR. That is PQR should be collinear. So PQR should be collinear, PQ should be parallel to PR. I can find this. What is PQ? PQ lambda minus nu minus 1. This should be parallel to PR lambda minus 1 minus gamma. This thing it should be parallel. So if it is parallel, it should be proportional. Lambda divided by lambda minus 1 equal to minus nu by minus 1 equal to minus 1 by minus gamma. It should be proportional like this. It should be proportional. So I can equate these two. Minus gamma equal to minus nu lambda plus nu. I can equate this and I can take common here, minus lambda plus nu lambda equal to nu. So what here? If you take lambda common, minus 1 plus nu equal to nu. So lambda equal to nu divided by nu minus 1. This is the first thing required. And what is another thing? This is lambda equal to nu divided by nu minus 1 and we can find the relation here. What we can find? Nu by 1 equal to 1 by gamma, gamma equal to 1 by nu. This is another relation. So from this relation, which mathematical rule is violating? We have to find. Here what is violating? Nu should not be equal to 1. Here nu should not be equal to 0. So when you substitute these 2 points, nu not equal to 1, nu equal to 0. That is, what is the general point given? The new point is here. So what is the point? What is a cube? Cannot be. Q cannot be 0, 1, 1. Yes. And Q cannot be 0, 0, 1. Yes. And also, I forgot to give the options, I think. Option A, K plus A. Option B, K cap. Option C, K cap plus half J cap. Option D, K cap minus half J cap. So I already said, this is 0, 0, 1. What is it is representing? It is K cap. So it cannot be a point. It cannot be a point. What are they are asking? They these points or cannot be a points. So it should not be option. And another point 0, 1, 1. So it will be here. It will be 0 into I plus 1 into J plus 1 into K. So it will be 0 plus J plus K or K plus J. It will be okay, correct. But these 2 points should not be, because it is violating the mathematical thing. That is, the denominator is becoming 0 when nu equal to 1, and here denominator becoming 0 when nu equal to 0. So these two things cannot be. So the remaining points, yes, it is, because after rejecting A and B, whatever points are coming, it can satisfy these things. This lambda and gamma things. Lambda and gamma things can be satisfied. So what we chosen is correct. So option C and D are correct. The 8th question is completed. Eighth question is completed. Now 9th question. Let P1 and P2 be 2 planes given by P1 10x plus 15y plus 12z equal to 60. This is one equation. And another plane equation they given, minus 2x plus 5y plus 4z minus, that is equal to 20. Another plane equation, which of the following straight lines can be an edge? Which of the following points can be an edge of some tetrahedron whose 2 faces lie on P1 and P2? Solution: option A, option B, option C. This question you have to do by yourself, but I will explain how to do, because it is very lengthy question and you have to think how you can do. I know how to do this question, but you have to do by yourself. So I am stopping the question after saying everything to you, because these types of questions will make you think. You can lose, but you can gain so much amount of concept here. So what they given? Let P1 and P2 be 2 planes. They given 2 planes here, and they are saying which of the following straight lines, these are the straight lines, can be the edge of the tetrahedron whose 2 faces lie on P1 and P2. Tetrahedron, you already know the tetrahedron. Suppose you can take a glimpse of this. You can take the glimpse of, this is the tetrahedron, and which of the following lines can be the edges of some tetrahedron if P1 and P2 lie on 2 faces. That is, if the tetrahedron 2 faces lie on the P1 and P2. Suppose if we assume this as P1 and if we assume this as P2, it is lying now. So what are the straight lines which can have the possibility to become the edges? That we have to solve. So first plane equation, 10x plus 15y plus 12z equal to 60. Another equation, minus 2x plus 5y plus 4z equal to 20. Using these 2 equations, I can find the line intersection. So because 2 planes are intersecting by a line, so that line can have the possibilities to become the straight line, anything edge. So I have to find the point of intersection. For finding point of intersection, I can eliminate one variable by just keeping z as 0, 10x plus 15y equal to 60, and minus 2x plus 5y equal to 20. What we can do here, we can divide it by 5 here. it will be like this. Addition 8y equal to 32, y equal to 4. When y equal to 4, x equal to 0. So 0, 4, 0. Understand? 0, 4, 0 is the point. And what is the direction now? The direction can be cross product I, j, k by using the points. That is 2, 2, 3. No, it is now we have to do directly. That is 12 minus 2, 5, 4, because we are not eliminating the anything. Here it will be 60 minus 60 minus j into 40 minus 12 is 24. It will be plus, and plus k into 50 plus 30. Yes, understand? It is 0. Here it is minus 64j, and here it is 80k. Yes, this is the thing. So what is the line of intersection now? The line of intersection is the passing point. The passing point is 0, 4, 0, x minus 0, y minus 0, z minus 0. And what are the directions? It has 0, it has minus 64, it has 80. But I can cancel these things. That is 16 4s, 16 5s. I can make it simple. Y minus 0 divided by minus 4, that equal to z minus 0 divided by 5. So this is the line of intersection. This is the line of intersection. Now I am taking this as lambda. Now what we can do? That is 0, minus 4 lambda, 5 lambda should lie in this plane equation. What are the two plane equations? It can lie when you substitute by the parametric. Now we have to search A, B, C, D from these options. If we equal to this complete equal to lambda, and if you solve this, and you will get for every plane you will get 2 points. That is, for this plane 1 you will get 1 point, this plane 2 you will get 1 point. So 2 points you will get. So what points it is satisfying? That points should be the lines. That point should be the edges. So here the edges can be A, B, D. So you have to solve it by yourself. A, B, D should be the lines. But how? You have to comment in the comment section. This is a 9th question. I explained completely and solved up to 75%. Remaining 25% you have to solve. Now the last 10th question. Let P be a point. Let P be a point in the first octant whose image Q in the plane x plus y equal to 3 lies on the z axis. Let z axis let the image of P let the image of P in the xy plane. Let the image of the P in the xy plane. Then the length PR is, what are they saying? Let P be the point in the first octant. There are octants, so let P be a point, and whose image Q in the plane. So this is a plane, and this is P point, and this Q is a point, that is this thing. So PQ is perpendicular to this plane. It is very clear. And let the image of the P, this image of the PQ lies in the z axis. Let image of the xy plane, then the length of the PR. Now they are asking what is the length of the PR. Now we can assume the points P point, Q point, R point as alpha, beta, gamma, because it is present in the first quadrant. Q, it is present in the z axis, and R, it is present in the octant only, alpha, beta, minus gamma. Now after finding these all things, if you can find PQ. What is PQ here? Alpha, beta, 0. So alpha, beta, 0, if you assume carefully, it is parallel to I plus j. Why? Because it's alpha, beta and 0, it is purely xy plane. It is I plus j. Now it is alpha I plus j. So now we can say alpha equal to beta from here, because it is present in that is, it is parallel to I plus j. Now this point is P, this point is Q. We can take the midpoint. What is midpoint? Alpha by 2, beta by 2 and gamma. This is the point, and this point, from this point it is clear, and if you, this is a midpoint and this midpoint is lying on the plane x plus y equal to 3. So alpha by 2 plus beta by 2 equal to 3, alpha plus beta equal to 6, and we know alpha plus beta, alpha equal to beta, so alpha equal to 3 here, beta equal to 3 here. So now alpha equal to 3, beta equal to 3, and now they are asking then the length of the PR. So now we have to report the length of the PR. So in order to report the length of the PR, it is very important to find what is gamma. So the gamma is this distance PR is 2 times. We have to multiply 2 times of the distance, and they said it is from the yz plane. So the distance is root of delta square plus gamma square. Delta plus square plus gamma square equal to 5. They given in the question. I forgot to mention it is 5, and the distance from the from the y-axis. From the y-axis, the distance towards the yz plane, it is 5. So now we already know what we know. It is delta plus gamma square, and delta plus gamma square. If you solve this, gamma will be equal to 16. The gamma square equal to 16. Gamma equal to 4. And when gamma equal to 4, now we have to multiply this thing. The gamma equal to 4, and this is 2 times of gamma. It is 2 into 4. It will be 8. Like this you have to solve. So that's it for this, guys. The 10 questions for 3D geometry is completed, and if you want this type of more sessions, you can subscribe to this channel and also hit the bell icon. And if anything is incorrect while I am solving, you can report in the comment section. I will try to answer whether it is correct or not. I can make sure that it is correct or not. And also, if you didn't join the Telegram group, join the Telegram group, because it is really important. And that's it for this, guys, for this video. And also all the best for your exams. Thank you.